still
improve.
be
I mean, the
they should still
previous one.
be in
Yes,
they
but
should
I'm
still
I'm
be
not
in the
being I'm not being able to log in. That is what I'm saying. So I'm not being able to log in here. Okay. So I don't know. I don't know. Okay. So okay, it logs in now. All right. Very good. Anyway, right.
oh
So
also the are you talking about the science books? Because
yes, yes. And
kind of
didn't you get the links up until now? Like the we should be
nope.
starting to study physics and chemistry as well. They cover a
Yep, but
significant
they're
portion as
not
well.
online. They're
And
not
not
online.
online. So could you be making PDFs? Okay.
Okay, I'll
So
try.
at least like we read a chapter, say for instance, for say almost 20 days maybe, or sometimes 15 days or 10 days at least. So every 10 days you will have to make a PDF. Okay. If you even find difficulty in making PDFs, just send me the images in WhatsApp. Okay. It will take maybe 10 minutes time. Okay. Every 10 days. Okay. In that way, it will be easier. Okay. Because I can like teach you from other resources, but it will be helpful for you if I teach you from the, what can I say, the resource of yours. Okay. All right. So now, what we said previously, the law shortage principle. First of all, let us try to understand about one direction reactions and both direction reactions. Okay. I know you know already know that, but still, let me show this to you. Say, for instance, if I write down a reaction, that is calcium oxide plus carbon dioxide, then calcium carbonate. Okay. So there is a one-signed arrow. That means these two will form together to become this compound. However, this calcium carbonate will not decompose into calcium oxide and calcium carbon dioxide. All right. This is the particular implication of this one direction reaction. Now, if I write down a two direction reaction or both direction reaction, that is N2 plus 3H2, then we are creating, say, 2NH2. Notice here nitrogen gas and hydrogen gas, okay, gas are creating ammonia gas. Okay. Now, whenever we are working with two directional reactions, the rate or speed of reaction becomes really important to consider. Because whenever we are like say working in the factory, we obviously want the reaction to be say consistent, or like it has to be like very smooth. Okay. We want the things to be very fast. Okay. But not only fast. Say for instance, if we are like say working fast, but the things are not like what can I say, working efficiently, say for instance. Okay. Or say we are like wanting say immense amount of pressure, which is very difficult for us to provide in the laboratory. Say for instance, I'm just giving you examples. Or say we are needing more temperature. More temperature means more energy. So the chemists or chemical scientists have to find a balance between all of these. Like what is the perfect amount of pressure, what is the perfect amount of temperature, and what is the perfect amount of substance that we should introduce. Like what are the substances? Here, nitrogen and hydrogen. Then the ammonia is being created. So we have to strike a balance between all of them to ensure the highest amount of productivity. We have to ensure the highest amount of productivity, right? Whenever we are creating any product, we have to like ensure that in the least cost we are being able to create the maximum amount of it, all right, or the maximum utilization of it. So that is why the rate of reaction becomes important. So what is the definition to that? The amount of product produced from reactant per unit time. Say for instance, these two ammonia, okay, or say 2 mole ammonia, it is being created per 1 second. Okay. So you would say that the rate of reaction is 2 mole per second. What did I say? 2 mole per second. Okay. And again, say if you are creating say 4 moles, then it would be 4 mole per second. Okay. So let's see. Okay, so for example, when silver nitrate is added to sodium chloride solution, it takes less than 1 second to create the white precipitate of ARYAN. All right, so let me write down the equation now. So silver nitrate. Are you understanding the things?
Yes.
All right. So silver chloride plus that would be sodium nitrate. Now, they say it is like taking 1 second, less than 1 second. All right, less than 1 second. Okay. To create the white precipitate, this was the sign. On the other hand, it takes years together for a bridge to rust. Okay. So this is a slow reaction to create the rust. Now, see, understand this thing. Like, do we want this reaction of creation of rust to be faster or slower? Tell me.
Slower.
Slower, right? So we would take measures to lessen the rate of reaction. So what do? We might like paint it, we might galvanize it, we might put some electroplates, all right? Do some electroplating to prevent it from getting into rust. Okay. Reactions that take less time have a higher rate of reaction, and reactions that take more time have a lower rate of reaction. Okay, there is no confusion. Okay, which will take less time? They have higher speed. Okay, if you replace rate with speed, if you remember, in say physics, what did we do? Meter per second, right? Meter per second. So more the second, less will be the speed. Okay, understand my point? Speed is sorry, velocity equals to distance over time. Remember, distance over
Yes.
time. So in this case, rate of reaction is like amount of production over time. Okay, so that means if it takes more time, the lower rate of reaction. If it takes less time, then say I mean more rate of reaction. Okay. Anyway, now let's come back to La Chatelier's principle. Okay, so La Chatelier's principle. So first of all, you need to understand whenever we are working with a both-sided reaction. Okay, what happens is, say, let me get back to the previous example, N2 plus 3H2 to NH3. Okay. Now, at first, there are, say, I have given, say, for instance, say, altogether, I have given 100 gram of product. I have given 100 gram of product. Okay. So, for instance, now, of them, some will turn into 2NH3. Say, for instance, after 10 minutes, 20 gram has turned into 2NH3, and in the left side, I have got 80 gram. Okay. Then again, this 20 gram will keep on turning to this side. Then into plus 3NH2 keeps turning on to this side. It keeps on going like this, and this. But at a certain time, what will happen is 50 gram, there will be present 50 gram of these two products. Sorry, what can I say? Reactants at first, okay? And 50 grams of 2NH3. Now, what this means is that the reaction has, reached its equilibrium state. What did I say? Reaction has reached its equilibrium state. What do you mean by that? It is that state where there is the same amount of reactant as the same amount of product. Understanding my point? Tell me.
Yes.
Okay.
Yes.
Now, another important thing is whenever we are considering both-sided reaction, especially for equilibrium state, it becomes really important that we understand what is the forward reaction and what is the backward reaction. So what is the forward reaction? What are the reactants at first? The reactants at first were N2 plus 3H2. So in this side, we have forward reaction. We have forward reaction. In this side, we have backward reaction. So these are the two reactions. What I mean by that is the creation of 2NH3 from N2 plus 3H2 would be forward reaction or considered as forward reaction. And creation of N2 plus 3H2 from 2NH3 would be considered as backward reaction. Okay. So why is that important? I will come back to that. Okay. But before that, tell me, do you understand forward reaction, backward reaction, equilibrium state, all of this?
Yeah.
Now see, if you see this graph, okay, first of all, see, with time, the rate of forward reaction keeps on decreasing. And with time, rate of backward reaction keeps on increasing. Why? Because the reactants or N2 plus CH2s are decreasing, right? If the amount of substance decrease, that means the rate of reaction will also decrease. Okay. Say, for instance, think about it. Say, if I put, say, 500 milliliter of H2SO4 in water in one case, and say 5 milliliter of water, sorry, H2SO4 in water, in which case will you see like very fast reaction or very fast reactivity? Obviously, in the first case, right? Is
Yes.
it correct? So that is what is
Yes.
happening. So at some stage, the rate of both reaction becomes equal. Why? Because the amount of substances becomes equal. Okay. Now here's a question to you. What do you think at equilibrium state when the amount of both substances say becomes equal? What do you think? Will the reaction stop there or it will be continuing? What do you think?
The reactions will stop there.
Reactions will stop there. Okay, why do you think so? Why do you think so?
Uh, Wait, no. They keep on going. Sorry, I meant to say they keep on going.
Right. They keep on going because you have some amount of left, right? The
Yeah.
rate of reactions will be same. The rate of reactions will be same, but that does not mean that reactions will end there. Okay, reactions doesn't end there. Okay. In fact, if you like introduce proper conditions to any chemical reaction, none of the chemical reactions will end. Okay, they will keep on continuing for the rest of their life. But obviously, at some stage, like say for instance, if I give you the reaction, say calcium oxide plus carbon dioxide, say calcium carbonate. Okay, say I'm willing to making it a both-sided reaction. Okay, but what you will see is at some point of time, carbon dioxide is vanished from the system. Carbon dioxide not present there. Okay, so there is, I mean, not all the reactions could be made to like both-sided reactions or maybe like say endless reactions. Okay, but say in this case or hypothetical scenario, the amount of substances in both sides of the reaction becomes same. In that scenario, rate of both reactions will be equal. Okay. So that is what the equilibrium state is. And there is one famous question that is prove that or like explain that the equilibrium state of a reaction is a dynamic state. It's not a say like a static state. Okay. We used to get 2 marks question based on that. I think this should be a question in your curriculum as well. Anyway, so I hope you understand this graph. So rate of reaction is being decreased, rate of forward reaction as the substance is being decreased, and rate of backward reaction is increasing as the substance or the product is increasing. Okay. Understand this graph. Understanding these graphs are really important. Tell me.
Yes, I can do this.
Now the next graph that is concentration and of product and reactant over time. Okay, it's also very easy to understand. If the amount of say like reactant is decreasing, that means its concentration will also keep on decreasing. And if the product's concentration is say sorry, I mean the product's amount is increasing, that means the concentration will also keep on increasing because concentration is mass over what density equals to mass over
Um,
volume.
vo- Volume. Yeah.
Anyway, like the more the mass, the more the density. That is what we read at least. That is what I remember. Okay. All right. So in equilibrium, concentration of both reactant and product are unchanged. Okay. So now notice that the concentration of both the things, I mean, it's very unlikely that they would be same. Now the answer to this is that the reactants and the products that will be created, they would be like different. And obviously the mole number should also be different. Okay. So the concentration of both the reactants and products should not be same. I haven't seen it, at least in any case. Okay. All right. So now, are these two graphs like clear to you? Tell me. Are
What do
these
you,
two
sorry, what
graphs? Yes, go ahead.
are these two graphs? What was the
I
question?
mean, do you have clear idea of these two graphs? If I tell you in exam that explain, I have given you this graph and tell you to explain this graph, will you be able to do that? Okay.
Um,
Or like
like
explain
90% sure, yeah.
uh, explain chemical equilibrium with respect to concentration versus time and rate of reaction versus time graphs. Okay. So will you be able to do that? That is what I was asking. Okay.
I'm like 85% sure. Yeah.
All right. All right. So that's good enough for now. Hmm. Now, okay, there are three principles. I don't think I will be able to get into three principles in detail. Just one principle, okay, just to get into that. Okay. So first principle is the effect of heat. Okay, so what is the La Chatelet's principle? First of all, La Chatelet's principle states that whenever a reaction reaches the equilibrium state, okay, if you change the amount of, say, reactant or product, or say you change the pressure in any of the sites, or if you change the temperature of that particular reaction, the reactions, say, what can I say? The rate of reaction or rate of forward reaction or rate of forward backward reaction will change. Now, how will it change? How will it change? Now, if you remember, just for effect of heat, let me explain it to you. I won't go get into the other tools. I know it's really late at night. So plus 92 kilojoule. So that means the forward reaction is exothermic, right? Because heat is being exerted. Understand the
Yes.
stress on the words. It is the forward reaction is exothermic because heat is being exerted into the system. Okay.
And I'm
The
guessing
forward reaction
the
is
opposite is endothermic.
yes. Okay. Because heat will be, what can I say, like absorbed is a term. Okay. Exothermic. And it is endothermic. Okay. Now, what will happen in case of adding heat? What will happen in case of adding heat? Tell me, what is your idea? What is your idea? What do you think will happen? Anyway, it's a principle, so there won't be like a lot of explanation, but let's see. Let's still see your views first. What do you think will happen if I add heat? My
Well,
hint
if
is
you get
that one of
exothermic,
the yes, I
if you get
mean one of the
exothermic, but
hint is
if you
that
combine both,
no, it won't be combined both. Like say for instance, in a equilibrium
okay,
state, what happens? Say the forward reaction and like a backward reaction, both of them have the same, say, what the same speed or same rate of reaction, right? Same rate of reaction. Is it correct?
yes.
Yes, same rate of reaction. That is what we studied. So now La Chatelier, or like a very famous chemist, he suggested that whenever you are changing the pressure, you are changing the temperature, you are changing the concentration of reactants, what will happen is the reaction, like it will act like in the opposite direction. Now, what do I mean by the opposite direction? Say, for instance, the forward reaction is exothermic. That means heat is being exerted. Okay. Okay. Now consider
Yes.
that addition of heat. That means I am like, say, heat is being increased, right? In case of a exothermic
Yes.
reaction also, heat is being increased. Okay. Because it is being exerted. All right. There is no confusion in that, right?
Yes.
So
No.
According to La Chatelet's principle, what will happen is the endothermic reaction or the backward reaction speed will increase. This is according to La Chatelet's principle. Now, why does it happen? I don't know the answer to that, but that is what La Chatelet's principle states. Okay, backward reaction. So backward reaction will increase. Now, what is the purpose or implication of that? That is, say for instance, if I'm willing to increase the production of ammonia, if I'm willing to increase the production of ammonia, if I keep on decreasing heat or absorb heat, okay, That means the amount of exothermic reaction or the rate of exothermic reaction will keep on increasing, right? Okay. Understanding your point? Understanding your point? Okay.
Yes.
So that is why these things are important. Okay. There is particular implication of the amount of pressure. Amount of pressure is related to the mole number of gaseous molecules. The more, what did I say? The pressure is related to
State.
mole number of gaseous states. Remember this thing, like, very importantly. Okay. Say, in this scenario, the pressure in the left side or pressure among the reactants is better. Why? Because there are 4 mole of gaseous molecules, and in the right side, there are 2 moles of gaseous molecules. That is why in the right side, the pressure is less. Okay. So we will see what is the effect of that as well. Okay. But not today, because I think you are already tired. But if you want me to continue, I can continue a little more.
Uh, no, it's all right. I'm probably gonna need to go to bed anyways.
Sorry, I didn't get you.
I probably it's been a bit. Yeah,
Okay, all right. So we will
I'm
continue
slurring
next
my
day. That
words
is
right
what
now,
you
so
are wanting,
yes.
right? Okay, all right, all right,
Yeah,
all right.
hopefully, yeah.
Okay, all right. So now, tomorrow I might be needing to do some work regarding project, or I might not be. But in case I don't notify you, I would like to take a class or tomorrow at 12 p.m. or 4 p.m. Is that okay with you?
Yes, I can.
12 p.m. or
Yeah.
4 p.m. Thursday. Okay, all right. Okay, all right. Allah Hafiz for today. And a very, very, I mean, many, many thanks to you. It's late at night,
That's all right. All
but
right.
and also
I,
like I was 20 minutes late, but you still allowed me to take the class. That's very
yeah,
thankful of
that's
you.
all right. I just annoyed my friend that they can't drive. It's all right.
Okay, all right.
I love this. Have a
Allah
wonderful
Hafiz.
day.
All
Good
right,
night
Allah.
from here, at
Okay,
least.
yeah,
I love this.
okay. Cool.